Yes.
So compound microscope, basically it is an extension of simple microscope, right? So what does a compound microscope do? It is used to see extremely small objects, right? We use it mostly in the biology lab to see certain germs and all other things. And basically it is going to consist of two lenses, right? So a lens of a short aperture and short focal length. So if there is a lens which is of a short aperture and short length, which is facing the object, it is given a name called as object lens, or you call it as objective lens. On the other hand, you have another lens of large focal length and large aperture. It is called as eye lens or eyepiece or ocular, right? The next question is, how are these two lenses placed? These are placed coaxially at the two ends of a tube. These are placed coaxially at the two ends of a tube. To focus over an object, the distance of the object lens from the object is adjusted with the help of an arrangement called as a rack and a pinion arrangement. Basically, you will have screws across which you can rotate and navigate, adjust the distance between the object and the lens accordingly. So when you take a small object and you place it just outside the focus of the objective lens, then what will happen is the first step will be a real inverted and magnified image. So the objective lens will first magnify the small image, right? And it produces a real and inverted image and give you that real and inverted image, right? So that image is going to act as an object for the next lens, that is the eyepiece, and that will further magnify the magnified image produced by the objective lens. Okay, so having that in mind, if you observe, so I didn't draw the diagram here.
Sir, here we have two cases now, sir. Least distance of distinction. So if we place it like lesser than 25 centimeter, no image will be formed.
Not lesser than 25. 25 like the image is formed actually. It is adjusted in such
least distance means if we keep it before the distance, it won't be formed. So not like that. Okay, sir.
Yes. Here the diagram is missing.
Yes.
Solution.
Yes.
The first part is The object is placed here, but the final image will be formed at the least distance of distinction. So that is why when they say when the image is formed at D. So in this case, what will happen is the magnifying power will be equal to MD. It is represented as MD, which is defined as the ratio of the visual angle subtended by the final image at the eye, that is beta, to the visual angle subtended by the object seen directly, which is alpha. So
okay.
magnifying power in this case is going to be equal to beta divided by alpha, but the angles are going to be so small that it will be tan beta divided by tan alpha. You can take it in this way. Okay, when you take it like this, if you observe, the diagram will be very simple. First, you need to understand that this object AB, which is placed in front of the objective, is going to form an image A dash B dash, which is real and inverted, right? It will be formed in such a way, it is between the focal length of, it is between the focus of the eyepiece and the optical center of the eyepiece. So that this image that is produced will act as an object for the eyepiece and produce a further magnified image A double dash B double dash at the least distance of distinction from the eye lens. Okay.
Sir, so the second image will be virtual.
Yes, it is virtual because it is between the focus and the optical center.
Yes,
right?
Yes.
1 minute.
Yes, sir.
Right. Now our job is to find the value of magnification. Magnification is very simple, right? It is tan beta by tan alpha. Look at the triangles, no? So for me to get tan beta, this is there, no?
Yes, sir.
So this is right.
A dash
Tan
B
beta will be equal to A double dash B double dash divided by A double dash C double dash. So it is going to be H dash by D.
Yes.
Okay. So this is tan beta. What is tan alpha? Tan alpha will be equal to
A double dash C dash by Q A double dash Q A double dash by
H divided by D.
Yes, sir. Okay.
Okay. So it is going to be H divided by D. So when you divide both, you will get tan beta divided by tan alpha, which is actually called as the magnifying power.
Yes.
H dash by H. It is basically the magnification of the lens. Okay. So the magnification, what you can do is you will apply the lens formula. So magnification is V naught by U naught. If you will apply the lens formula, 1 by V minus 1 by U is equal to 1 by F. You will apply it for the eyepiece. So 1 divided by V is minus D minus 1 by UE is minus UE is equal to 1 divided by FE. Okay. So multiply with D on both the sides. So D divided by UE will be equal to 1 plus D divided by FE. Okay.
Yes,
this D divided by UE is the magnification produced due to the eyepiece. Magnification produced due to the objective will be V naught by U naught.
So V naught by U naught will be beta by alpha.
Very good.
Yes.